Today we are going to talk about a geometric term called an angle. We will be using angles from now until the end of the year, so it's important that you know about them, know how to write about them, know how to discuss them, know the parts of them. So an angle consists of two rays with the same endpoint, where each side of the angle is a ray and the endpoint is the vertex of the angle. So if we look at the picture down here, and then we'll write about it, we have our vertex right here, and we have two rays that form the angle. Now, there are numerous ways to name an angle. So let's pretend that we have point A, F, G. So for this angle, we could talk about it as angle F, the vertex. We could call it angle AFG. We could also call it angle GFA. And sometimes what will happen is they will put a number here, like say, oh, this is angle number 1. So then you could write that as angle 1. Notice that is not the measurement of the angle, it's just a way to label the angle. Most likely, we will be using the 3-letter namings of these angles because it kind of gives you a map of exactly what angle you are talking about. So we have angle AFG, meaning we start at A, we go to F, and then we go to G. It's very clear what angle we are talking about. Same thing with angle GFA. Start at G, go to F, go to A. Again, it's very clear what angle we are talking about. We'll get into some situations where if we say angle F, it might be a little bit confusing exactly what angle we are referring to. But sometimes we can use that if it's clear that there's only one angle that we're talking about. And this will make more sense when we look at some constructions and figures and start talking about angles. But just know that when you use 3 letters to name an angle, the vertex must be in the middle. So see the vertex is F. We have F as our vertex. We could not say, oh, angle F, G, A. We couldn't say that. That would mean G would be the vertex, and it's clearly not the case here. There are some different types of angles that we're going to talk about. We have what's called an acute angle. It's an angle that measures between 0 and 90 degrees. So if we had angle that looked like this, we call this angle GRB. This is an acute angle, and as long as it measures less than 90 degrees, so maybe the measure of angle GRB is equal to 50 degrees. That would be an acute angle. A right angle is an angle that measures exactly 90 degrees. Think about a corner. That is a right angle. So if we have this figure, we get R, S, T. Now, get in the habit of looking for little boxes in our right angles. This looks like it's a right angle. It looks like a corner. But if we see this box here in the corner where the angle is formed, that's how you can tell that this is a 90-degree angle or a right angle. So means right angle. And the measure of angle RST is equal to 90 degrees. And then an obtuse angle is an angle that's between 90 and 180 degrees. So an angle like this let me see, C, S, F. So the measure of angle CSF, clearly this is open more than 100 or more than 90 degrees. So as long as it's more than that, we're okay. So let's say it's 130 degrees. So those are the three types of angles that you will need to know how to recognize. Acute, angles that are less than 90, right angles, which are exactly 90, and obtuse angles that are exactly 90 degrees. Sometimes we will have something called straight angles. And what that is, it's when an angle measures exactly 180 degrees. So think about a line. A line is 180 degrees. So that is what a straight angle would be. So if we had this RGB. So if this is a straight line, we would say the measure of angle RGB is 180 degrees. And then we have something that's called an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So if we have and then a ray here, such that these two angles are congruent, we do little arcs to show that those two angles are congruent. Just like with segments, I'm going to erase this in a minute. If we had two congruent segments, we had little tick marks there to show that they were congruent. These little arc markings show that these two angles are congruent. So this right here, this is an angle bisector. And then congruent angles would have the same measure. So if these all had points, A, F, K, S, we would say that angle AFK, so the measure of angle AFK is equal to the measure of angle KFS. Now again, you could go in a different order. I could have said angle SFK, and that would have been the same thing. So these two angles have the same measurements. That means they're also congruent. So we can write that as angle AFK is congruent to angle KFS. Remember, if we're talking about an actual object, those objects are congruent. If we're talking about the measurements or the length of something, those are equal. So we see M for measurement, we have equal sign. We don't have measurements in front here, so that's why we have the congruent sign instead. Let's look at some examples. Name three angles in the diagram. So we have this whole angle A, B, D. So angle A, B, D, or angle D, B, A. We have each part of this now, angle ABC. So angle ABC or angle CBA. And then we have angle CBD. So angle CBD or angle DBC. Now remember at the beginning I said that we should most always use the three letters and not just the vertex when naming the angles. And this is an example why. If I said angle B, which one of these three angles am I talking about if all I say is angle B? So because they have a shared vertex, we should not just call this angle B when talking about this figure. We should be very specific about which one of these angles am I talking about. All right, let's talk about how to use a protractor. So we have our paper one here, and we can use some real ones later on, but I think it's a good way to kind of get an idea of how to use one. So if I want to find the angle or the measurement of angle WSR, start WSR. Okay. So this is the angle I want to use. I'm going to be using the outside numbers because the horizontal line that my protractor is lined up with is on the left. So that means I want to use the outside numbers. So let's see, where does that intersect? It looks like between 60 and 70, so let's call that 65 degrees. Now, another way you could have figured out which set of numbers to use is, if you messed up and used the inside numbers, you'd say, oh, between 110 and 120, that's 115 degrees. Well, this angle is clearly less than a corner, so it should be less than 90. So even if you don't remember the rule, just kind of think about it and use common sense. Say, hey, this angle is less than 90 degrees, so we should be using the outside numbers. Now angle TSW. Angle TSW. Okay, so this is the angle we're talking about. And again, you could say, well, this is bigger than a corner, so it's bigger than 90 degrees, so let's use the inside number. Or you could use the rule, all right, if my horizontal line is on the right of the vertex, then I'm going to use the inside numbers. Honestly, what I just do is I say, okay, this is bigger than 90 degrees, so I'm going to use the numbers that are bigger than 90 degrees. So between 110 and 120 is 115 degrees. Then angle RST. Well, RST is a straight line. That's 180 degrees. And then angle VST. Let's look at VST. That is a perfect corner, making this 90 degrees. So using a protractor isn't all that difficult once you've actually had some practice doing it. We're going to name all the angles in the diagram. So again, I always start with the biggest one here, FGH. So angle FGH. And then I go for the smaller ones, FGJ. And HGJ. Now you could have just those three, or you could say, well, what about going in the other direction? Angle HGF. Yep, these two are not different angles. They're the same angle, but different ways of naming them. And then we can also have angle JGF. And we can have angle JGH. Now, good question will be, how do I know, or how do you know as a student, am I just looking for like 3 of them, or do I want all 6? The directions say name all the angles. And since these two are technically the same angle, you don't need both. You could just give me one or the other. Up here, I specifically said or, meaning I wanted both names for that angle. These two, like I said in blue, are the same angle. All right, the last example, what type of angles do the x and y axis form in the coordinate plane? So remember, our x and y axis look like this, and they form right angles. These are perpendicular lines. We have a right angle. So they form right angles. And then we have two more definitions to talk about. First one is parallel lines. If they do not intersect and are coplanar, then they are parallel lines. So like these two lines here, they are parallel. They don't touch, they don't cross. If we label line L and N, the way we would notate that is we would say L, and then these two lines right here, that's a symbol for parallel to N. That says that line L is parallel to line N. Real life example of that would be some of the streets that you have in your neighborhood. In my neighborhood, my street and the street on the other side of the block, they go in the same direction. They never touch. So streets are parallel. If you look at the lines in your driveway, look at a slab of concrete in your driveway, and the two ends, that little groove, they're parallel. They don't touch. So there's a lot of examples of parallel lines. Now, perpendicular lines, those lines form a 90-degree angle. We could have these two lines here. Let's make these different. Let's make them actual lines and not segments. So, and again, we need this little box here to show that it's a 90-degree angle there. And let's call these lines R and S. So the notation we would use would be R, and it's an upside down T for perpendicular. That's a symbol for perpendicular to S. So line R is perpendicular to line S. So you do need to understand what these two symbols mean, because we're going to start constructing, math sentences, and instead of writing out the word perpendicular or parallel all the time, we're going to use the symbols instead. And then the example, or an example for perpendicular lines, again, you could also look at the streets. My street and the main road that it connects to are perpendicular. But I won't use that one. Again, what about the bricks on the side of your house? The bricks in my house, I have where they connect, they connect perpendicularly. They form a right angle. I've seen patio stones that are connected in a way that are perpendicular. When you build a wall and you have the wood that connects perpendicular. Even the walls themselves, the wall in my living room, the two of them connect at a perpendicular angle. So let's go with walls in a house. So that was an introduction on angles. You will need to really understand what angles are and how to label them and to talk about them. So if you need to go back and review this, go ahead and do that. Otherwise, thanks for watching. Bye.